I'm Dr. James Giordano. I'm currently serving as the director for the Center of Disruptive Technology and Future Warfare at the Institute of National Security Studies at the National Defense University in Washington, D.C. And I'm also a professor emeritus of neurology, biochemistry, and ethics at Georgetown University Medical School at Washington, D.C. My background is that I'm trained as a neuroscientist and neuroethicist. My academic background is both in molecular and cellular neuropathology, as well as in political philosophy of science and technology. And I've been working in this field for about 40 years. For about the best 30 of those years, a lot of my work has been involved with the international use, governance, oversight, regulation, and in some cases, proscription of the uses of neuroscience and technology in those ways that might be, as we refer to, dual-use research of concern, and or the uptake of neuroscience and neurotechnologies into various initiatives and operations within military, intelligence, and national security agendas. We have to move away from what I would call more esoteric philosophical discussions of free will. And I think that the nature of those discussions is certainly rich. And one could argue, for example, that free will represents an artifact, that we really don't have free will. We are, in fact, something of a biological quasi-automaton. I don't agree with that. I think that really it is a question more of level rather than kind. And I think that what ends up happening is that our free will becomes manifest as a consequence of our conscious intentionality. And we align those intentionalities with a set of values and norms, very often that are shaped by increasing circles and circumferences of others, initially immediate family, more distal family, friends, colleagues, etc., and then ultimately creating that level of social inculcation and reinforcement that allows us to then develop our norms and mores, which then allows us to be able to align, if you will, our own decisional compass, if you will, our moral compass, with those things that we find to be most socially acceptable, so as to be able to function as an integrative unit within our culture or our collectives. And this is basically a very fundamental, a very generalized discussion of how morality develops from individuals to collectives and groups. But I think the idea of an individual's free will, in other words, developing intentionality, motivation, and then acting on that intentionality and motivation, involves a variety of brain nodes and networks. The question then becomes, can those brain nodes and networks be both accessed and affected in ways that in some way redirect, or if you will, usurp the individual user's mechanisms and processes of directionality, and therefore create some modicum of externalization of control? The short answer to that question is yes, indeed they can. And this is why it becomes so important to be able to develop both biosecurity by design and ethical probity, ethical moral rectitude, into the way that these assessment and interventional neurotechnologies are developed and are articulated in various forms of application. The reason being is that by accessing the brain, we're able to affect its functions. Its functions, I think, cumulatively can be referred to as mind. And if we look at what those functions are cognition, inclusive of the emotional dimension of cognition, and the execution of behaviors. And we know from a very long history, even going from very crude neurotechnologies to the most sophisticated neurotechnologies that we have currently available on the global stage, that each and all of those processes is certainly accessible, and to some extent, affectable. So it becomes very, very important to understand the individual's level of consent to be able to have these technologies utilized upon them and perhaps others, and then also define what the contingencies are for consent with regard to understanding and elucidating the benefits, the burdens, the risks, and the potential harms of both commission, doing the thing, and or omission, so that individuals are well aware, both individually as well as collectively, what these neurotechnologies can be used for, are being used for, and should not be used to do. I mean, if we look at the Oxford English Dictionary, there are really two intersecting definitions. One, I think, is far more realistic, and the other is far more colloquial. The realistic one is weapons really just represent anything that could be means of contending against others so as to be able to modify their intentionality, their emotionality, and or their action, very often in ways that are therefore consistent with what you desire them to be. In other words, weapons are change agents. They are artifacts and instruments of change agency. And I mean, we see that used colloquially as well. We can say that, oh, this person's sense of humor is a real weapon, or we say this person's eyes are actually a weapon. And I mean, obviously, they're not using them to harm, but what they are using them to do is to disarm, to change our own sentiments and perhaps our own actions in ways that would therefore be the intent of whoever is wielding that weapon. And we know that. I mean, a very good comedian, a very sardonic or sarcastic comedian, utilizes humor, sarcasm, and wit in a weaponized way to disarm others, very often in ways that allow them to then gain humor and perhaps also make them somewhat more affiliative. We know this. So a weapon need not necessarily be something that is capricious or nefarious, but is certainly something that one can yield so as to affect others. And in that way, the range of that effect then can go across a spectrum. The more colloquial use of the word weapon, not necessarily in such a benign way, is that those things that can be used not only to affect others, but to affect others in such a way that induces some level of burden, risk, or harm. And in this way, what it does is it modifies their intentionality and or their actions in ways that are in accordance with the one who is wielding the weapon. In other words, I use the weapon to get someone to yield to my intentions, my motivations, and my desires. And in so doing, I can shape their behavior in particular ways. And in shaping their behavior in particular ways, I can do that by inducing certain behaviors. I can make them do certain things, or I can inhibit them from doing certain things. And here, too, this goes along a pretty broad range. I could, for example, make them surrender to my will, to my cognitions, to my desires, my intentions. Or I could simply make them stop behaving in a particular way. So if we look at weapon in that sense, we can then fit any prefix into that then utilizes these artifacts, these instruments, and these intents within a particular set of systems, mechanisms, or processes. So if we talk about neuroweapons, what we're really talking about here are those things that can be used to work upon the peripheral and central nervous system in those ways that are going to be able to affect the cognitions, emotions, and behaviors of others in those ways that we desire them to be affected, and characteristically in those ways, in the more traditional contexts, that then allow us, those who are yielding the weapon, to leverage some capability, if not power, over them, those who are then subjected to the weapon. So if we think about it in those terms, what neuroweapons are those tools, those techniques, those means, and those methods of affecting the peripheral and central nervous system in ways that modify the thoughts, the feelings, and the actions of others in those ways or in those dimensions that are intentional, that we perceive as either being offensively or defensively problematic for us. So we can then utilize these weapons in ways that are what we call kinetic. In other words, we can actually use them in sort of a combative way, but we can also use them in ways that are far more non-kinetic, in a more influential, perhaps disruptive and or deterrent way. But they still fall into categorical weapons based upon a very formal definition of what a weapon is and how a weapon is used. The notion of cognitive warfare in the cognitive domain is not simply the province of the CCP. I mean, we know that from the early aughts here in the United States and also in the EU, there's been an interest in not only the viability of neuroscience to be utilized in those ways that have some import for national security, intelligence, and defense agendas, initiatives, and operations, but how the neurosciences could be used and should and perhaps should not be used. Now, that being the case, there have been a number of ongoing discussions, both here in the United States and internationally, particularly among the EC countries, the European Commission countries, and it was a large incentive initiative of the European Union Human Brain Project, which I had the privilege and honor of working on with a number of colleagues, to specifically look at duly usable brain sciences and what types of things would need to be considered as weaponizable and what types of oversight guidelines, governances, and controls would then need to be incorporated into signatory treaties and international conventions so as to align these new developments in the brain sciences with some of the constraints, controls, oversights, surveillances, and parameters of those international signatory treaties. That being the case, I think an important consideration was also, well, what are we learning about brains, both individually and collectively, that in some way can be manipulated or can be utilized within these larger agendas of international discourse? So when we're talking about cognitive warfare, now things get a little fuzzy, because now what we're really talking about is not necessarily things that directly affect the brain. In other words, we're not talking about drugs, bugs, toxins, devices, but now we're talking about information, understanding how individual and collective brains work in various cognitive processes of individual interaction and collective interaction, so as to be able to affect individuals' thought processes, their attitudes, their sentiments, their values, and their behaviors. So this idea of cognitive warfare, working primarily in the non-kinetic domain, in other words, utilizing information, leveraging narratives, iconographies, semiotics in ways that the brain sciences, particularly the cognitive neurosciences and social neurosciences, have revealed to be important and influential to individuals and groups, takes us into a new, if you will, battlescape. And the battlescape exists on two levels. One is direct engagement of the brain. Now we're talking about, if you would, neurowarfare. And those that involve more indirect engagement of the brain, utilizing all the classic tools of individual and social interaction on a variety of scales, literally from the individual all the way to the international. This has been a large focus not only of the CCP in recent years, but also of the North Atlantic Treaty Organization. And here I refer you to a series of documents that, once again, I had the privilege and honor of working with my colleague Franz de Klusel in developing the initial policy statement with regard to cognitive warfare and NATO's interest in and engagement in cognitive warfare and what that might mean on the 21st century global stage, and how that NATO discussion was then more broadly applied to a number of NATO allies, as well as a number of international allies, inclusive of Trans-Pacific allies, to be able to understand how contemporary progress in the neurocognitive sciences can be uptaken into these agendas of national interest, national security, intelligence, and defense in those ways that are leverageable over individuals and groups, to target those individuals and groups in ways that may then be able to direct and or influence national and or non-state actor hegemonies. I mean, the idea of utilizing informational capability to be able to affect individual and collective sentiments, attitudes, values, norms, and practices, well, this has been long known. I mean, realistically, this grows out of a field that is colloquially referred to as neuromarketing. In other words, understanding how individual and collective groups of cognitive processes operate, so as to be able to then use key aspects of narrative, symbols, environment to influence those individuals, literally utilizing what we know about the neurosciences to develop marketing approaches to be able to affect people's values and values desiderata and their various choices, actions, and behaviors, as well as the underlying sentiments. Well, now applying that more broadly, I think, takes on a very deeper level of psychological operations and perhaps imbues to propaganda, literally propagating ideas and infiltrating those ideas to influence key individuals and or groups so as to direct, once again, their attitudes, their sentiments, their values, and the behaviors that arise from and are directed by them. So this is becoming a very sort of hot topic, if you will. Clearly, the ubiquity of information that is available over the internet, the I think proliferance of individuals having access to social media, literally everyone being somewhat connected to some extent, then allows these vehicles of social media and this level of internet connectedness to become a vector, a nexus, and a tool through which these various aspects of narrative, symbol, semiotics, iconographies can then be manifest and expressed to key targetable audiences, both individuals and groups. So clearly, one thing that can be done is utilizing the electromagnetic spectrum of information transfer as a vehicle and vector to be able to then get this information in ways that are in some way affecting others by virtue of both subtle and covert manipulation. And I'm not using the word in a derogatory way. What I'm saying is manipulation literally, like sort of manhandling, if you will, the way individuals' cognitive processes work, and as a consequence, what things they like, they don't, their sentiments, their values, and their behaviors. But I think we can go one step further. We can also see that some of these tools are also recognizing that the brain, as an electromagnetic organ, is therefore sensitive to a variety of energies that may be directable. And now we're talking about directed energy weapons and or directed energy devices that could be weaponized. And we're looking at a broad spectrum. For example, we're looking at directable and rangeable acoustics and sonics, ultrasound and infrasound. We're looking at various forms of other energetics, lasers, rapidly pulsed microwaves. And we recognize that each and all of those things speak to particular vulnerabilities in the way the human nervous system operates that can be affected by a variety of these tools that are increasing in their capability and sophistication as a consequence of their technological development and readiness. We can't simply usurp information from someone's brain from a distance. We're not able to do that yet. The ability to remotely sense brain activity at the level that allows us to then interpret that activity to construct from those patterns of neurological electrical signaling cogent thoughts. We're not there. We're not at that point yet. Are we close? Well, I think we're certainly in the waiting room. Let me give you an example. There are two lines of projects, paradigmatic projects that I think are showing what I would call intentional progress in that area. One is the use of interpretive AI, large volume machine learning coupled with big data approaches, to be able to interpret neuroimaging patterns and signals. So what we're able to do is we're able to reconstruct various visual stimuli, auditory stimuli, tactile stimuli that an individual is exposed to or is feeling based upon a pattern reconstruction of a neuroimage of their brain, a very sophisticated form of neuroimaging that utilizes functional MR, functional magnetic resonance imaging, together with various types of track tracing. And from that, we can utilize AI and other forms of integrative machine learning based upon hierarchical data integration to essentially re-engineer what the brain is interpreting from this individual's sensory input. That's still very rudimentary. But again, we've been doing this work for about 20 years. So rudimentary as it may be, it's had a 20-year history of iterative development and is becoming more capable. That's point number one. The limitation there, of course, is that you still have to put the individual into a neuroimaging scanner. So this cannot be done clandestinely or covertly. You have to put the individual into the scanner, number one. And number two, it requires serial evaluation. So it's not a one-shot scan and then you're able to completely reconstruct a relative pattern of this brain activity and from that reverse sort of instruct or reverse create what this individual's sensorium was at the time of the image. There's an awful lot of software, hardware, and blood, sweat, and toil, so to speak, that go into that. So this cannot be done clandestinely or covertly. That's number one. The other approach that I think is showing, considerable progress is the use of very, very small-scale sensors and transmitters that can be input to the brain non-surgically. And this is a current DARPA project, Defense Advanced Research Projects Agency project, that is referred to as N-cubed, which refers to next-generation, non-invasive or minimally invasive neuromodulation. And it involves the use of neuroengineered sensors and transmitters that can be introduced to the brain space non-surgically, either via inhalation, injection, ingestion, absorption through a mucous membrane, migrated into the brain space utilizing some form of magnetic current due to the particular properties of these nano-engineered materials, and then utilizing this migrational pattern to form a relatively vast array of sensors and transmitters within the brain that allow real-time reading of information from the brain and writing of information to the brain remotely. Now, this is the one that gets, I think, really provocative, and I think in part of that provocativity, there's a particular contentiousness. If we consider that the functions of the brain writ large could be construed as mind, and axiomatically, this is a project that seeks to read information from the brain and write information into the living brain remotely in real time, then I don't care how you twist this. This represents some iteration, some construal of, quote, mind reading and mind control. Yes, indeed, it does. But here, too, there's an awful lot of distance between alpha and Zulu, if you will, between, alpha and omega, so to speak. Number one, the technology readiness stage of this project is still somewhat nascent and incipient. Number two, it does require a fair amount of hardware to do this. Number three, it is in its early stages and therefore is in an evaluative stage. So the clarity, the fidelity of the signaling, both reading from and writing in, are at a very early developmental stage. But it represents, if you will, a rocket in that direction. And if you really sort of analogously relate this back to a space program or a moonshot, those early rockets were instrumental because those early rockets were proof of concept. We can. Now it's just a question of, if we can get something into space, into orbit, can we break out of Earth orbit? Can we get into lunar orbit? Can we land on the moon? So the questions here are, can we do this? Yes, we can. Can we infiltrate the brain space non-surgically, embed within the brain a vast array of nanomaterials that are capable of sensing and transmitting remotely in real time? And can we then use those aforementioned programs of machine learning and AI, utilizing various types of heterogeneous data, to then read from the brain and be able to interpret those electromagnetic signals of the brain in such a way as to reconstruct patterns of brain activity that can then be construed as viable cognitions, sensations, etc.? And can you then be able to transmit information back into the brain in such a way that is going to be uptaken by the brain and then translated into some aspect of cognition, perhaps emotion, and perhaps also some execution of action behavior? So we're on that path. Where are we on the path? In other words, are we at the base of the mountain? Are we on the apex of the mountain? We're certainly not at the apex of the mountain. We're about a quarter of the way up. But what it's demonstrating is directionality. What it's demonstrating is intentionality and iterative capability. So although we're not at the point right now, to your earlier comment about, do we need to be worried about people literally, quote, reading our minds as we're walking around and putting information into our brains and therefore controlling our behavior surreptitiously and or reading our thoughts surreptitiously? No, we don't. Might it be a concern in the future? Yes. But perhaps a larger concern and a more immediate concern, what I would consider to be a clear and present concern, is the use of various technologies, inclusive, for example, certain types of drugs, certain types of microbes, certain types of directable energies that can affect individuals and groups of individuals in ways that they may not be aware at the time, to be able to induce effects that may be initially subtle, but are nonetheless profound in terms of altering their capabilities of thought, their clarity of thought, their ability to function, the types of thoughts they have, although we're not able to actually insert various types of thoughts, but certainly clarity of thought, vigilance, capability of thought, clear-mindedness, and or a host of physiological functions, their balance, their coordination, their ability to do a job, their health. Yes, these things, those particular, what I would call targetable entities, represent a clear and present concern, and certainly within the scope of consideration, concern, consternation. And what we're pressing for at this point is the need for much more stringent oversight, regulation, guidance, and governance. So the, quote, elegance of nanomaterials is that because of their fairly small size, again, the scale is smaller than a cell, they're able to penetrate the physical and chemical barriers that block access from the bloodstream into the brain. This is called the blood-brain barrier, and there's also a second barrier that exists in the fluid that bathes the brain and the brain tissue called the blood-cerebrospinal fluid barrier. And these are both physical barriers in terms of the permeability of things coming out of the bloodstream into the brain space, but they're also chemical. They also have an ionic charge, and certain things need to be chaperoned across that barrier. But using nanomaterials, you're essentially getting, if you will, two capabilities in one. Number one, their small size makes some of these easily accessible across these barriers, but also you can imbue them with particular physical characteristics that allow them to then electrochemically go across these barriers because, if you will, they have the right credentials, so to speak. In other words, they have the ID card that allows them to transfer across the blood-brain and blood-cerebrospinal fluid barriers. So the, quote, beauty, the technical beauty of these nanomaterials is that they can be engineered in such a way that allow an increased penetration to the brain space. Now, could there be some capricious, concerning, and/or nefarious use of these? Could they, in fact, be inflicted upon an individual without this individual knowing? Well, yeah, actually they could. But let's back up. Remember that the sophistication and capability of the technology and science necessary to do these very, very specific tasks that are part of this directable research program that DARPA is undertaking, whereby we're able to get these materials into the body, migrate the materials into the brain space, establish these materials into a structural array that allows their functional capability to both sense what's going on in key areas and nodes and networks of the brain, and then transmit back into them. Well, this requires specificity. This requires dedication. This requires the adherence to specific protocols. But one of the things that my research group has been worried about is the use of nanomaterials more crudely. Nanomaterials that can be introduced very easily into a body by virtue of aerosolization, solubilization within various liquids, or impregnation onto various materials that are then uptaken into the oral mucosa, that are inhaled, that may be touched, that we know are going to migrate into the bloodstream, and we know are capable of migrating into the brain. And if they migrate into the bloodstream and into the brain, they can do two things. Number one, they can aggregate in the bloodstream of the brain, and they can induce problems with the vascular penetration or the vascular flow of the brain. In other words, they can cause what appears to be a stroke, and/or they can actually disrupt the node and network electrical ionic communication of the brain, and they can serve as network disruptors that can then change cognitive capability, motoric capability, coordination, functionality in ways that are generally nonspecific, but are no less disruptive. So the use of nanomaterials for rather crude, but certainly capable clandestine, if not covert weapons that are able to disrupt various aspects and domains of brain function, that's a real worry for us. You know, one of the issues when we're talking about the nanomaterials is you need to have proximity to the target. So these are what we sometimes call an in-close deployment. In other words, these are not weapons of, quote, mass destruction. You're not going to sort of perfuse these across a broad area, but rather they're more instruments of very specific disruption. You're looking to disrupt particular types of function or domains of function in a very selected key target, a high-value target or a group of individuals who, if you affect these individuals, the value of them as targeted individuals is highly disruptive and/or can have ripple destructive effects on some aspect of their role, their function, or some other aspect of their individual capability, their group capability, and therefore their hierarchical functionality. But if you're looking at things like directable energies, whether it's sonic energy, infrasound, or ultrasound, or whether it's something further along the electromagnetic spectrum, for example, lasers and/or rapidly pulsed microwaves, well, these things, number one, are directable. Number two, they can be used with relative clandestine, if not covert capability. And then the question is, well, can we shield ourselves from these things? And the answer there is yes. So there are ways of, number one, detecting that these types of things are operational. Environmental detection, architectural detection, personal detection. And then once these things are being detected, at that point we can then deter them. We can deter them environmentally, we can deter them architecturally within particular buildings, for example, by establishing Faraday cages. And there are also ways that we can deter them and defend individuals physiologically and individually, personally, bodily. So I think it becomes important to understand that as the technology develops that has particular capability to affect individuals, concomitantly there are science and technology developing in those ways that are going to be able to protect individuals should these technologies be used in those ways that are capable of disruption, destruction, and harm. The case example, the exemplar, is what has been referred to in the media as the Havana syndrome, where individuals, the prototypic individuals, were about 24 individuals who were working at the United States Embassy in Havana, Cuba, were exposed to some form of directable energy or energies that induced very, very profound physiological effects, cognitive disruptions in these individuals' capability for neurological function, integration, balance problems, autonomic system problems, and then long-term health problems that continue to persist. More formally, these are referred to as anomalous health incidences, AHIs. And although the prototypic cases, at least as far as much of the media were concerned, occurred in Havana, there had been previous cases that had occurred elsewhere, probably representative of iterative development of these devices to be used against both surveillance equipment, communication equipment, and certainly against human targets. But Havana has sort of become the hallmark set of cases. Number one, because they were aggregate cases in one place. Number two, the individuals were a very select group of individuals. And number three, it seemed to be a relative turning point in what we view to be the technological development not only of a single type of directed energy device, but the use of multiple types of directed energy devices, both singularly and combination. And again, here we're talking about sonic devices, infra and ultrasound, coupled with other forms of electromagnetic directable energies such as lasers and rapidly pulsed microwaves. And subsequent to those cases that occurred in Havana in 2016, there have been other cases worldwide that are suggestive, if not wholly indicative of the fact, that these types of things continue and these devices can be utilized in disruptive ways. I'm not so much worried about the nanomanufacturing because nanomanufacturing does require a significant amount of hardware, a significant amount of software, and a significant amount of infrastructure. That's not to say that malicious non-state actors and or proxies could not obtain those materials from a state that has particular interests in using those materials in ways that would be capricious and nefarious. I mean, that's certainly possible. But we're really far more worried at this point about other forms of neuroscientific and neurotechnological developments that are fieldable, that are scalable, and therefore are operationalizable. And you have those things that sort of fall within the more traditional categories of biological and chemical weapons. So various forms of pharmacological agents, case in point, for example, being the agent Novichok that has been used internationally as an assassination agent. It's a central nervous system acting agent that has been used, for example, by Russia. But there are others. The use of particular microbes that can be now engineered with relative specificity and ease, utilizing synthetic biological and gene editing techniques. So now we can take essentially benign microbes and make them far more problematic, far more pathologic. We can essentially re-engineer existing microbes to be these ways, or we can develop microbes anew to develop what we've referred to as precision pathologies that are capable of targeting particular individuals, groups of individuals based upon their genotype or based upon particular characteristics of their physiology, which is called their phenotype. That's a real worry. Obviously, we're also worried about the use of certain toxins, not only organic toxins that would need to be extracted from a variety of different organic species, venomous snakes, venomous mollusks, various algae, but also that now can be synthetically biologically manufactured to have more stable properties, and these are very, very potent neurotoxins that can be delivered at very, very low doses and that can be highly morbid and in many cases mortal, lethal. Very, very difficult to then obtain evidence of this because of the very low doses that are used, and these can be very potentially used as assassination agents against very specific targets. Could these fall into the hands of non-state actors? Yes, absolutely. Could they be provided to proxies? Yes, absolutely. Could they be used by state agents and actors in ways that target specific individuals for clandestine engagement? Yes, absolutely. And then, of course, we're looking at devices and neurotechnologies. So now we're getting back to the idea of directable energies. And I think we also do need to be concerned about the potential capability of state actors, particularly state actors that exist within authoritarian regimes, to make particular demands that these technologies be implemented for social control, for various forms of occupational control, inclusive of occupational performance optimization. And now we fall into a sort of a different domain, which is the use of neuroscience and neurotechnology to optimize the performance of individuals who are functional in various aspects of national security, intelligence, and defense. So now we're talking about the idea of manufacturing the colloquial super soldier or super spook. I think at very, very least, what we need to do is something that I and many of my colleagues have been advocating for at least the past 15 years, is a revisitation and revision of the language, the specificity, and also the orientation of international signatory treaties and conventions, such as the Biological Toxins and Weapons Conventions and Chemical Weapons Convention. So, for example, in the UK, my esteemed colleague, Dr. Malcolm Dando, has been very, very vocal with regard to revisions of the Chemical Weapons Convention to include those agents that are sort of coming out of the laboratory forefront, experimental forefront of the neurosciences that have dual usability. He's also addressed some of the biological agents that we've spoken about here today. My group has advocated very strongly that it becomes very important to address not only these existing categories of those agents that we know are weaponizable and therefore may have some nefarious use, but also to change the categorical focus of these conventions and treaties to be more appreciative and therefore more acknowledging of the capabilities rendered by gene editing techniques and synthetic biology, and also to include various forms of devices with regard to their weaponizability and dual usability. And the good news there is that the Australia Convention, the Australia delegation to the Biological Toxins and Weapons Convention has, for the past 10 years, been arguing very strongly in these domains directions with intents. And our group, working with others internationally, has also advocated very strongly for a revision of these international signatory treaties and conventions, as well as the establishment of guidelines and governances and regulatory frameworks anew that remain apace, if not ahead of some of these developments, so as to be able to allow a bit of flexibility with regard to their governance and with regard to their regulatory capability, so as to sustain their fixity of purpose, so as to be able to maintain that level of oversight, maintain that level of regulation, surveillance, governance, and control. If we're talking about an open liberal democracy, then the idea of individual rights and liberties needs to be exercised. And certainly, I think that there's a very strong trend and tendency in that domain. So I think when you're dealing with an open democracy, a liberal democracy, certainly it comes down to the idea of consent and what is consentable and what are the contingencies of consent. And I've written about that considerably in the published media. Where things get a little problematic is where there are sort of sweeping leverageable capabilities and hegemonies within the corporate infrastructure. In other words, if you want to retain your job, you must. And very often those things could be guised under what I would call performative parameters. In other words, we're monitoring you so as to make sure that we're providing you these necessary environments that you keep your performance high. Okay, at face value, that may be an acceptable criterion. However, we have to be very, very cautious because here too need to be the representative and necessary stops so as to prevent that slope from becoming slippery. A slope is only slippery when, in fact, the stops are taken out, but recognizing where the stops have to be so that we don't slip down a slope that ultimately becomes irretrievable. So one of the things that we worry about is the idea of iterative neurocorrectives. Right? So if what we're doing is we're monitoring function, cerebral function, particular parameters of cognitive and or behavioral function, and we're doing that in a real-time, relatively proactive way. And what we find is that individuals are not necessarily performing according to some neurocognitive thresholding that we would say represents the viable threshold for certain performative aspects. Well, the next step is, what are you going to do about that? Well, I think the easiest way is, this is an individual who might need to be counseled, or this is an individual who might need to have certain perks or certain incentivizations so as they're then making sure their performance increases. But it's a very, very short trip from utilizing neuroscience and technology to assess cognitive behavioral functions and outputs to then utilizing some form of neuroscience and technology to affect their performance towards optimization of key aspects of cognitive and behavioral outputs. So these are the things that we're very, very concerned about because we see these as flowing along a relative continuum of capability, which then certainly needs some form of oversight, guidance, and regulation. I occasionally will do some posting on LinkedIn. I have something called Neuroscapes, where I post every couple of weeks about ongoing developments in the brain sciences, neurotechnology, and ethics. And they can certainly find me online. I do have an online presence. My work here at the National Defense University is very, very strongly oriented towards providing the level of international oversight and regulation of those ways that the brain sciences could be uptaken into these various military intelligence agenda, and what types of things need to be instituted so as to maintain the probity, regulatory, and governance capability of those international signatory treaties and conventions that maintain that level of ethical and moral oversight on the world stage. So again, I'm free to look me up online.